What if I told you there was a single geometric idea that could connect computer science, the laws of physics, and, believe it or not, even the reason we laugh? Well, today we're diving into a pretty wild theory that claims to do exactly that.
So let's start with something we all know. You know that feeling when you hear a joke or a really sharp observation and you just laugh almost before your brain has even had a chance to process it? Why on earth does that happen?
The theory we're exploring today suggests the answer isn't just about psychology. Nope, it's actually a clue to how our physical bodies are interacting with reality itself.
Okay, so here's the core concept. The source material basically says that your body, your whole nervous system, is like this super high-speed truth detector. It's running millions of checks in parallel, constantly measuring reality, way before your conscious, logical mind even gets its coffee in the morning.
And right here, this is where the conflict happens. You've got two systems going at once. Your body just resonates with the truth instantly, kind of like a tuning fork, vibrating when it hears the right note. But your mind, it's slower. It's methodical. It has to take this new piece of info and check it against every single thing you already believe. And that creates a delay, a time lag.
So what is laughter then? Well, according to this theory, it's the energy that gets released in that gap. It's the physical, audible proof that your body got the truth, while your brain is still lagging behind trying to catch up. It is literally the sound of a truth smashing through your own cognitive firewalls.
Okay, so we start with humor, but things expand really fast. The theory argues that this gap, this delay between physical recognition and mental acceptance, it isn't just about jokes. It's a fundamental property of information itself.
And this is where we take the big leap. What if that whole body-mind lag, that feeling of resonance, isn't just a weird quirk of human perception? What if it's pointing to a deep property of information itself?
And here it is, the central claim of this entire framework. The argument is that information isn't just abstract ones and zeros floating around. It has a physical, geometric structure. It has a shape. And just like the geometry of space-time creates gravity, the geometry of information is said to have its own very real physical effects.
So this one idea that information has a shape is the master key. From this single claim, the theory says three massive conclusions just fall right out. That simply existing costs energy, that information comes in these tiny, unbreakable packets, and that the universe itself is basically made of pixels.
All right, let's grab onto that last one for a second, because that is a real mind-bender. This idea that reality isn't smooth and continuous, but is actually discrete. Let's just walk through the logic here, okay? Step 1. If information has a physical shape, then there must be a smallest possible piece of it, a quantum of information. You can't just keep cutting it in half forever. Step 2. If you buy into the idea from digital physics that physical reality is, at its core, made of information, well then, step 3 becomes pretty much unavoidable. Reality itself has to be built out of these minimum units.
Think of it like a super high-resolution TV screen. From your couch, it looks like a perfectly smooth, continuous image, right? But if you get right up close, you see the individual pixels. This theory claims the universe is just like that. At the unbelievably tiny Planck scale, space and time aren't smooth. They're made of these little four-dimensional pixels, or voxels. And this, by the way, solves ancient paradoxes like Zeno's. You know, the one about never reaching a destination? Well, you can't divide a distance in half forever, because eventually, you hit a single pixel.
Okay, a pixelated universe is a huge claim. You've got to be wondering, where does this idea of informational geometry even come from? The answer is, not at all what you'd expect.
Yeah, I mean, an idea this big didn't come from a particle accelerator or from staring through a telescope. The source for this theory claims it all started with one of the most famous and famously difficult unsolved problems in all of computer science.
This is the P versus NP problem. To put it simply, it asks, if checking the answer to a problem is super easy and fast, does that automatically mean that finding the answer from scratch is also easy and fast? Most experts think the answer is no, but proving it has been basically impossible. There's even a $1 million prize for it.
Now, the author of this theory claims to have solved it by borrowing a concept from Einstein's special relativity. They frame verifying an answer and finding an answer as two totally different informational reference frames. Think about it this way. Checking an answer you already have is like standing still. It's easy, you're at rest. But finding that answer from scratch, that's like having to travel through a vast space of possibilities just to get there.
And that idea leads to this proposed equation, which looks a whole lot like the equations from relativity. It basically says the time it takes to solve a problem is the time it takes to check it times this gamma factor. In relativity, gamma gets bigger the faster you go through space. Here, this informational gamma gets bigger the harder the problem is. For those really tough NP problems, this factor becomes gigantic, creating a fundamental geometric gap. And that gap, they argue, is the proof that P does not equal NP. And it's this geometric structure that they then apply to, well, everything else.
And this brings us to the final and maybe the most profound consequence of this whole geometric framework, the actual cost of existence itself.
So think about it. If moving through informational space has a geometric cost, the theory argues that simply existing in that space has to have a cost too. This cost of being is the tiny, constant drip of energy that any defined thing, a particle, a memory, a bit of data, has to pay just to stay distinct, just to be something instead of nothing. Existence, it claims, is not free.
And wow, this slide really shows you the sheer ambition of this theory. This is a diagram the author calls the psychic hegemony. Psychic has to do with the mind or soul, and it tries to map everything onto this geometric framework. Don't worry about all the details, but just look. You can see these different quadrants for logic, morality, physics. It's a blueprint for a theory of everything, and it's all built from this one core idea about the geometry of information.
Okay, let's bring this all back down to something we can feel. Ever wonder why your brain, which is only about 2% of your body weight, burns through 20% of your energy? This theory has an answer. Consciousness is an unbelievably complex informational state, and maintaining all that complexity has a very high cost of being. That exhaustion you feel after a day of just intense thinking? According to this, that's you paying the literal physical price of being conscious.
And we'll end on this final, pretty powerful thought from the source. It reframes our entire existence not as something that just is, but as an active, energy-burning process. What started with a simple chuckle over a true joke ends with a fundamental question about the price of reality itself. A question rooted, of all places, in the geometry of definition.